Okay, so here is a demonstration where Manish sir is trying to explain that what would happen to the spool when it is placed like this. As you can see over here, there is a platform and the spool actually rolls on this platform. Now, it is the inner part of the spool that is rolling. So the outer circumference is not rolling, but the inner circumference which is rolling. So the question is that if the spool rolls, then what would be the distance that would be traveled by this by an object which is placed on the the outer circumference? So if let's say I put a slab over here, how much distance would this slab travel in comparison to distance traveled by the center of the spool? So let's just see what happens over here.
पहले ये जमीन पर चल रहा था, अब ये बीच में जो इसका जो जगह बची है उसके ऊपर चल रहा है. So now if I move my hand, you can see and you will see that this time if I move my hand this much, 3 गुना ज्यादा चल जाता है.
So now the question is, how do we prove this? Okay, so let's see. Okay, now as you can see that this is our spool and this is that inner circle which actually is rolling, right? And at this point O, you have put your load which ultimately moves a little further than the center. Now let's try to figure out what do we actually know. So the first thing that we know is that there is no slipping. So in the case of no slipping, the point of contact P is actually not moving. Its velocity is 0. How is that possible? That is possible when it is rotating and there is some tangential velocity because of the rotation, but at the same time the entire thing is moving in the forward direction. So the tangential velocity because of the rotation, which is omega r1, must be equal to the velocity of the center but also in the opposite direction, and hence the velocity of the center of the spool is actually equal to the velocity which is tangential velocity at P. And this gives us what? This gives us the velocity of center in terms of r1 and omega, which is the angular speed of the spool. The angular speed of the spool is same for every point, right? However, now we have got the velocity of center in terms of omega and the radius 1, which is the inner radius, right? Now what do we need to understand? So once we have got this relationship, what do we now want to find out is what is the velocity of the outermost point. And the velocity of the outermost point is pretty simple to understand. This point is moving forward because the spool is moving clockwise direction. But it is not moving forward only because of that. It is moving forward also because of the fact that the spool itself is moving forward. So the velocity of point O is nothing but the tangential velocity that it gets because of the rotation plus the translational velocity of the center. So omega r2 plus v center. Overall, v center plus omega r2 is the velocity of O. Now if you want to find out the ratio of the distance traveled by a load placed on O and the distance traveled by center, then it is very simple. You just have to multiply the velocity of point O with t, which is omega r2 into t plus omega r1 into t. Omega r2, remember, is the tangential velocity of point O and omega r1 is the translational velocity of the spool. And this has to be divided by the velocity of the center, which is nothing but omega r1 into t, and this t gets cancelled. What is left is just this r2 upon r1 plus 1, and this gives us the speed by which a point over here can move and the ratio of that speed with or the distance that an object that is placed at this point O can move and the ratio of the distance of this object and the ratio and the distance that is traveled by the center of the spool, right? And as we see that the larger the r2 is, the greater the distance you are going to travel, or the larger the r2 by r1 is. So if I can somehow increase this r2, so in our case what happened was r2 was twice r1 and hence the ratio became 3. R2 could be thrice r1 as well and the ratio would become 4. R2 could be 4 times r1 and the ratio would become 5. So that's how you can ensure that the center does not travel a lot. However, anything that is placed on the top travels much further than that.